In this video, I am going to explain about the Virtual Device Context or VDC. The Virtual Device Context or VDC is used to virtualize the Nexus 7000 switch, meaning presenting the Nexus 7000 switch as multiple logical switches. Within a VDC, you can have a unique set of VLANs and VRFs, allowing the virtualization of the control plane. Each VDC will have its own administrative domain, allowing the management plane as well to be virtualized. You can assign a line card to a VDC or a set of ports to the VDC. Without creating any VDC on the Nexus 7000, the control plane runs a single VDC. Within this VDC are multiple processes and layer 2 and layer 3 services running, as you can see in this figure. This VDC is always active and cannot be deleted. Actually, here you can see single VDC operation mode, a structure, kernel, infrastructure, and then layer 2 services and layer 3 services. Layer 2 services like spanning tree protocol or STP, private VLAN or PVLAN, VLAN manager, and also switch virtual interface or SVI. About the layer 3 services, we have RIB routing information base, FIB forwarding information base, VRFs means virtual routing and forwarding, and also the routing protocols. Virtualization using VLANs and VRFs within this VDC can still be used. When enabling multiple VDCs, these processes are replicated for each VDC. Within each VDC, you can have duplicate VLAN name and VRF names, meaning you can have VRF production in VDC1 and VRF production in VDC2. When enabling role-based access control or RBAC for each VDC administrator will interface with the process for his or her own VDC. This figure shows what the structure looks like when creating multiple VDCs. As you can see here, you can have fault isolation, separate administration per VDC, separate data traffic, and hardware partitioning. Also, the following are typical use case for the Cisco Nexus 7000 VDC, which can be used in the design of the data center. First, creation of separate production or deployment and test environments. Creation of intranet, extranet, and DMZ. Creation of separate organization on the same physical switch. Creation of separate application environments. And creation of separate department for the same organization due to different administration domains. Here you can see multiple VDC operation mode structure, VDC1, VDC2. In VDC1 we have routing protocols, VRFs, SVI, HSRP, GLBP, CTS, STP, and other features. And in other VDCs also we have all of these features. VDC separation is industry certified. It has NSS labs for payment card industry or PCI compliant environments, Federal Information Processing Standard or FIPS 140-2 certification, and Common Criteria Evaluation and Validation Scheme CCEVS with the number 10349 certification with EAL4 conformance. Alright, now let me to explain about the VDC deployment scenarios. There are multiple deployment scenarios using the VDCs, which enable the reduction of the physical footprint in the data center, which in turn saves space, power, and cooling. The first method is horizontal consolidation scenarios. VDCs can be used to consolidate multiple physical devices that share the same function role. In horizontal consolidation, you can consolidate core functions and aggregations functions. For example, using a pair of Nexus 7000 switches, you can build two redundant data center cores, which can be useful in facilitating migration scenarios. This can happen by creating two VDCs, as you can see in the left figure. VDC1 will accommodate core A and VDC2 will accommodate core B. You can allocate ports or line cards to the VDCs, and after the migration you can reallocate the old core ports to the new core. Aggregation layers can also be consolidated. So rather than building a separate aggregation layer for test and development, you can create multiple VDCs called Aggregation 1 and Aggregation 2. Aggregation 1 and Aggregation 2 are completely isolated with a separate role-based access and separate configuration file. The right figure shows multiple aggregation layers created on the same physical devices. The next method is the vertical consolidation scenarios. When using VDCs in vertical consolidation, you can consolidate core functions and aggregation functions. For example, using a pair of Nexus 7000 switches, you can build a redundant core and aggregation layer. Although the port count is the same, it can be useful because it reduces the number of physical switches. This can happen by creating two VDCs, as you can see in the left figure. VDC1 accommodates core A and aggregation A, and VDC2 accommodates core B and aggregation B. You can allocate ports or line cards to the VDCs. Another scenario is consolidation of core aggregation and access, while you maintain the same hierarchy. This figure, the right figure, shows that scenario. As you can see, we used a pair of Nexus 7000 switches to build a three-tier architecture. The next scenario is VDC for service insertion. VDCs can be used for service insertion and policy enforcement. By creating two separate VDC for two logical areas inside and outside, as you can see in this figure, for traffic to cross VDC A to go to VDC B, it must pass through the firewall. This design can make service insertion more deterministic and secure. Each VDC has its own administrative domain and traffic must go out VDC A to reach VDC B. The only way is through the firewall. Alright, now let me to explain about the different types of VDCs. As explained earlier in this video, the NX OS on the Nexus 7000 supports Virtual Device Context or VDC. VDC simply partition the physical Nexus device into multiple logical devices with a separate control plane, data plane, and management plane. Connecting two VDCs on the same physical switch must be done through external cables. You cannot connect VDCs together from inside the chassis. It is important. The following list describes the different types of VDCs that can be created on the Nexus 7000. First, about the default VDC. When you first log into the Nexus 7000, you log into the default VDC. You must be in the default VDC or the admin VDC. I will explain about the admin VDC in this video in a next step to do certain tasks. You must be in the default VDC or admin VDC, which can be done only in these two VDC types. The default VDC is a full function VDC. The admin always uses it to manage the physical device and other VDC created. It's important. The admin always uses it to manage the physical device and other VDC created. The default VDC has certain characteristics and tasks that can only be done in the default VDC, which can be summarized in the following. First, VDC creation, deletion, and suspend. Resource allocation means interface or memory. NX OS upgrade across all VDCs. And then EPLD upgrade, don't worry about the detail of them, as directed but by TAC, means a Technical Assistance Center, or to enable new features. And also Analyzer capture control plane traffic. Then feature set installation for Nexus 2000 Fabric Pass and FCOE. And then control plane policing or COP. Port channel load balancing, hardware IDS checks control, and ACL capture feature enabled. Okay, with CPU shares, you don't dedicate a CPU to a VDC rather than giving access and assigning priorities to the CPUs. Okay, CPU shares are supported only with Supervisor 2 or 2E. The next type of VDC is non-default VDC. The non-default VDC is a fully functional VDC that can be created from the default VDC or the admin VDC. Changes in the non-default VDC affect only that VDC. An independent process is started for each protocol per VDC created. There is a separate configuration file per VDC, and each VDC has its own RBAC, SNMP, and so on. About the admin VDC, the admin VDC actually is used for administration function. You can enable starting actually this mode from NX OS 6.1 for Supervisor 2 and 2E modules, and starting from NX OS 6.2 for Supervisor 1 module. You can create the admin VDC in different ways. First, during a fresh switch boot, you will be prompted to select an admin VDC. Enter the system admin VDC command after boot, and in this case the default VDC become the admin VDC, and all non-global configuration in the default VDC will be lost. And also enter the switch admin VDC migrate then the new VDC name command. All non-global configuration on the default VDC again will be migrated to the new VDC. The admin VDC has certain characteristics that are unique to the admin VDC. First, features and feature sets cannot be enabled in an admin VDC. You cannot assign any interface to the admin VDC. Only management 0 or MGMT 0 can be assigned to the admin VDC. When you enable the admin VDC, it replaces the default VDC. You must be careful or you will lose the non-global configuration. And finally, after the admin VDC is created, it cannot be deleted or changed back to the default VDC. To change back to the default VDC, you must erase the configuration and do a fresh boot script. Creating the admin VDC doesn't require the advanced package license or VDC license. The next VDC type is the storage VDC. The storage VDC is a non-default VDC that helps maintain the operation model when the customer has a LAN admin and also a SAN admin. The storage VDC relies on the FCOE license and doesn't need a VDC license. The storage VDC counts toward the total number of VDCs. We can create only one storage VDC on the physical device. After the creation of the storage VDC, we assign interfaces to it. There are two types of interfaces: dedicated FCOE interfaces or shared interfaces, which can carry both Ethernet and FCOE traffic. This figure shows the two types of ports. Here you can see dedicated interface for a storage VDC, and here you can see shared interface for a storage VDC. As you can see in the shared interface, both of these two types, Ethernet VDC and storage VDC, can use actually this shared interface. With Supervisor 1, you can have up to 4 VDCs and 1 admin VDC, which requires 8 GB of RAM because you must upgrade to NX OS 6.2. Supervisor Engine 2 can have up to 4 VDCs and 1 admin VDC. With Supervisor Engine 2E, you can have up to 8 VDCs and 1 admin VDC. Beyond 4 VDCs on Supervisor 2E, we require a license to increment the VDCs with an additional 4. About the interface allocation, actually the only thing you can assign to a VDC are the physical ports. At the beginning and before creating a VDC, all interfaces belong to the default VDC. After you create a VDC, you start assigning interfaces to that VDC. A physical interface can belong to only one VDC at a given time. But when you create a shared interface, the physical interface belongs to one Ethernet VDC and one storage VDC at the same time. When you allocate the physical interface to a VDC, all configuration that existed on it get erased, and the physical interface gets configured within the VDC. Logical interfaces such as tunnel interface and switch virtual interface are created within the VDC, and within a VDC, physical and logical interfaces can be assigned to VLANs or VRFs.